Hello students, let's solve last question of this exercise 12.4 and also last question of this chapter, question number 2. Use the given algebraic expression to complete the table of number patterns. Here one table is given. In this number one expression is given, that is 2n minus 1. Now when we take n is equal to 1 and we find the value of this expression, we get first term. When we take n is equal to 2 and find the value of this expression, we get second term. This way this table is written. So for 2n minus 1, first term is 1, second term is 3, third term, that is n is equal to 3, if we take the third term we get 5. For this expression 2n minus 1, for fourth it is 7, fifth it is 9, 10th it is 19 and 100th we have to find. Next expression 3n plus 2, first term is 5, second term is 8, third term is 11, fourth term is 14, fifth, 10th and 100th term we have to find. Expression third 4n plus 1, first term is 5, second term is 9, third term is 13, fourth term is 17, fifth, 10th and 100th term we have to find. Same way in expression 7n plus 20, fifth, 10th and 100th term we have to find. And n square plus 1 expression we have to find fifth and 10th term. 100th term is given, that is 10,001. So let's solve this sum. Number 1 expression is given 2n minus 1 and we have to find 100th term. 100th term means n is equal to 100. So here we will write putting n is equal to 100 and therefore our expression 2n minus 1 is equal to, instead of n we have to write 100, that is 2 multiplied by 100 in bracket minus 1. 2 multiplied by 100, that is 200 minus 1, that is equal to 199. Next, for expression 3n plus 2 we have to find fifth term, 10th term and 100th term. So for first fifth term, putting n is equal to 5. For fifth term it is 5. So therefore our expression 3n plus 2 is equal to, instead of n we have to write 5, that is 3 multiplied by 5 bracket close plus 2. 3 5 is 15 plus 2, that is equal to 17. Next, for 10th term, putting n is equal to 10 and therefore expression 3n plus 2 is equal to 3 multiplied by n, that is 3 multiplied by 10 plus 2. 3 tens are 30 plus 2 and that is equal to 32. And for 100th term, putting n is equal to 100 and therefore our expression is 3n plus 2, that is equal to 3 multiplied by 100 plus 2 and that is equal to 300 plus 2, that is equal to 302. Next expression 4n plus 1. We have to find fifth term, 10th term and 100th term. So for fifth term, putting n is equal to 5. Therefore expression 4n plus 1 is equal to 4 multiplied by n, that is 5 plus 1. 4 5s are 20 plus 1, that is equal to 21. Next, for 10th term, putting n is equal to 10 and therefore expression 4n plus 1 is equal to 4 multiplied by n, that is 10 plus 1. 4 tens are 40 plus 1, that is equal to 41. And last, 100th term is putting n is equal to 100, therefore expression 4n plus 1 is equal to 4 multiplied by n, that is 100 plus 1. 4 multiplied by 100, it is 400 plus 1, that is equal to 401. Next expression 7n plus 20 for fifth term. So putting n is equal to 5, therefore expression 7n plus 20 is equal to 7 multiplied by n, that is 7 multiplied by, instead of n we have to write 5 plus 20. 7 5s are 35 plus 20, and that is equal to, it is 55. Next, for 10th term, putting n is equal to 10, and therefore expression 7n plus 20, that is equal to 7 multiplied by n, that is 10 plus 20. 7 tens are 70 plus 20, that is equal to 90. And for 100th term, putting n is equal to 100, and therefore expression 7n plus 20 is equal to 7 multiplied by n, that is 100 bracket close plus 20. 7 multiplied by 100, that is 700 plus 20, and that is equal to 720. Last expression, n square plus 1. Here we have to find 5th and 10th term. So here for 5th term, putting n is equal to 5, and therefore expression n square plus 1 is equal to, instead of n we have to write 5. So it is 5 square plus 1. 5 square means 5 multiplied by 5 plus 1. 5 5s are 25 plus 1, that is equal to 26. Next, for 10th term, putting n is equal to 10, and therefore expression n square plus 1 is equal to, instead of n we have to write 10. So it is 10 square plus 1. 10 square means 10 multiplied by 10 bracket close plus 1, that is equal to 10 multiplied by 10, 100 plus 1, that is equal to 101 is our answer. Students, let us revise what we have learned in this chapter. We have learned about algebraic expressions. They are formed using variable and constants. Variable, here x is a variable, phi is a constant. Also they are formed using operations, arithmetic operations, addition, subtraction, multiplication and division. Here in this expression, addition is used. Then we have learned about terms. Terms are nothing but a part of an expression. Here x plus 5, x is the first term and phi is the second term, and they are added. Terms are added to the other terms. Then we have learned about factors. Here 4xy, factors are 4, x and y. Here x and y are algebraic factors. Then we have learned about coefficient, numerical coefficient. In 4xy, 4 is a numerical coefficient. In general, we can say in 4xy, x is a coefficient of other factors, that is x is a coefficient of 4y, y is a coefficient of 4x. Then we have learned about polynomials. Polynomials are an expression which have one or more than one terms. If there is a single term, we call it monomial. If two terms, we call it binomial, and for three terms we call it trinomial. Then we have learned about like and unlike terms. Like terms means if in two or more than two terms variable is same and their power is also same, then they are called like terms. For an example, here 4x and 3x. Here variable is x and their power, that is 1 is also same. So that's why 4x and 3x are like terms. Unlike terms means their variables are not same. If variables are same, then we have to see the powers. If powers are not same, then they are called unlike terms. So here 4x and 3y, here variable is x and y, they are not same. That's why these two terms are unlike terms. Then we have learned about the sum or difference of two like terms. Sum is nothing but a sum of numerical coefficient of like terms, and difference is difference of numerical coefficient of like terms. For an example, 4x plus 3x, that is equal to 7x, and 4x minus 3x, that is equal to x. Then we have learned that when we add unlike terms, they are left as they are. Also we have learned value of an expression, and value of expression is totally dependent on value of variable. Then we have learned about formulas using algebraic expressions, and also we have learned the rules for number patterns. Thank you.